In 6.1, we looked at probability distributions. Now we're going to look at a specific type, and it's called a binomial distribution. A binomial distribution has some key features. The first one is that there's a fixed number of trials, I should say of trials are conducted. So a fixed number. There are two possible outcomes for each trial. Success or failure. That's it. The probability of success is the same every time. So that's got to be consistent. And the trials have to be independent. That means that one trial does not affect the next trial. So they have to be independent. So the probability has to be the same. They have to be independent, so they're not affecting each other. Two possible outcomes only, and it's a fixed number of trials. Now, this can be done in the calculator. So this is going to be in the distribution menu, and I'll show you that in a second. If we're looking for the probability of something happening, it's going to be Binom PDF. And if we want the probability that it's less than something, it's CDF. I don't know where the C comes from. Don't ask me. Okay. So, in a recent poll, 10% of adults said that they consider themselves to be gamers. Assume that 18 adults are randomly sampled. So, it's a fixed number, and they're either saying they are or they aren't. And that's what we've got. So the probability of success is 10%. Let's call that the success. Success is 10%. So let's look at how this would line up in the calculator. So we're going to go into the calculator, and this is under a distribution menu. It's under VARs. It's blue, D-I-S-T-R. So we're going to press second VARs. So second VARs is the distribution menu. And binomial is down a ways, and we want binomial PDF. So let me talk about what we're going to see. Binom PDF. Okay, so when I press this, it asks me several things. It says trials, P, and then X value. How many trials are being performed in this example? Well, 18. What's the probability of success? So this is the probability of success. Now we need to know this X value. So the first one says, what's the probability that exactly 3, that X equals 3. So we're just going to put in the X value of 3. So the trials is 18.10. You don't have to put the 0. And we want to know what's the probability of exactly 3 people saying that they consider themselves gamers. Oh, I had a negative from a previous problem. Oh, that's not good. Let's clear that. 0.168. Now sometimes it's helpful on these problems to actually make a table of all the options. I find that to be helpful. So X and P of X, We already know the probability of 3. Let's see. And on the next one it said fewer than 2, so that means the probability of 0 or 1. Probability that x is 0 or probability of a 1. Yeah, I'll put the x equals, you really don't need that. Probability 0 or 1. Well, I could do them each in the calculator and then add them together. So that's one method of doing this. And you can actually go in here if you wanted to just edit and change that to a 0 instead of a 3. You could do it this way instead of going back through that whole process. And change that to a 1, and then it's a little bit faster, 0.30. So if I added those together, it'd be 0.45. But there's also a way to do this quicker, especially if there's more, and that is with what is called the CDF. So if I wanted the probability, and it's less than or equal to, so it'd actually be less than, that x is less than or equal to 1 is what we'd have to use. If we wanted to do that probability, we would use the binom CDF. And so second distribution, CDF, 18.1, and less than or equal to 1 gives me 0.45 as well. So if you want to do a less than or equal to, that would be CDF, or you can just kind of make a table of it, whichever way. Now, compute the probability that more than 2 of them consider themselves gamers. Well, the CDF only does less than. More than 2, well, how about we do 1 minus the probability that x is less than or equal to 2. Well, what's the probability of x being less than or equal to 2? Well, that would be the CDF thing. That'd be CDF. So I could just go up here and change, instead of 1 as my boundary, change that to a 2. So that is 0.734. And I'm going to do 1 minus that. You can technically do 1 minus, and just highlight it. 0.266. Now the last one, compute the probability that the number who consider themselves gamers is between 1 and 4. Well, that would just be between 1 and 4. So there's several ways I could do that. You could find the probability of 2, find the probability of 4, and just add those up. I'm going to actually do that. I'm going to show you different ways you can do this. So I'm going to use the PDF, find the probability that x is 2, and that's 0.284. And then I'm going to change the 2 to a 4. I want to show you all different ways to do it, and that's 0.07. Let's check some of these we did. Less than or equal to 2 would have been this, plus 0.45. Yeah, that would be 0.734. Cool. Between 1 and 4, you could add up these 4. So between 1 and 4, 0.3 plus 0.284. So you could make a table Uh-oh. Did I type something in wrong? I did. Because it should never be bigger than 1. I put my decimal in the wrong spot. That should be 0.822. Okay. Well, couldn't I also do the probability that x is less than or equal to 4 and then subtract out the probability that x is 0? Ooh. Okay, so I'm going to go find the CDF one again. Probability being less than or equal to 4 is 0.972, and the probability of getting a 0 is 0.15, so minus 0.15 gives me 0.822. Oh! So there's several ways to find these. You can make a table of all of your distributions and add them up. Finding each individual one is the PDF. Less than or equal to is CDF. Now, for mean, variance, and standard deviation. This one, the formulas are the easiest route. I know you want to use the calculator. If you wanted to make the table in the calculator, you would actually have to make the full table, all 18 options. That would take a while. The formulas are actually faster. So let's talk about, and we're going to use this new example. Gregory Mendel discovered the basic laws of heredity by studying pea plants. In one experiment, he produced plants whose parent plants contain genes for both green and yellow pods. His theory states that the offspring of 2 such parents has probability 0.75 of having green pods. Assume that 80 such plants are produced. So our number is 80, and our probability of getting the green is 0.75. So that's the success in this case. The mean. The formula says we're just going to take the number total possible times that probability. Oh my gosh. 80 times 0.75. 80 times 0.75. These formulas are not hard. That means about 60 plants are going to have green pods. Average 60 plants have green pods. And that makes sense if 75% of them have a chance of having green pods. Now, standard deviation and variance. So, variance using a formula is actually easier to get. Now remember, variance is the standard deviation squared. But the formula for variance is easier. It says n times p, right, we just found that, times 1 minus p. Well, 1 minus p means I'm just going to take 1 minus 0.75. So I've got the 80 times 0.75 times 0.25. Well, I already did the 80 times the 0.75, so now I just need to multiply by 0.25. The variance is 15. Now, how would I find the standard deviation? Well, variance is standard deviation squared, so all I have to do is take the square root of 15. So the square root of 15. And that's about 3.87. These formulas are really easy, and these formulas are on your formula chart.